All right, so let's continue let's start our understanding of our step functions. Part A, what is the graph of a ceiling function? So just a reminder, a ceiling function is a kind of step function. It rounds numbers up to the nearest integer. So I'm going to go ahead and fill in a table of values of x, just the x values, and then we will apply the ceiling function, get some y values, and then we will talk about how that looks on a graph. So let's say our x's are, we're just going to go down this first column, negative 2.4, negative 1.4, negative 0.5, 0.7, 1.8, 2.1, and 3.1. So if we apply the ceiling function to these x values, what that means is we're going to do the ceiling function of negative 2.4. It's going to round that up to the nearest integer. We're on the negative side, so we have to be careful. Would that round it to a negative 3 or a negative 2? Which one is considered bigger? It's actually going to be the negative 2. All right, then we're going to apply the ceiling function to negative 1.4. It's going to round it up to a negative 1. Ceiling function to negative 0.5 is going to round it up to a 0. And then once we get positives, it's a little bit easier. If you take that 0.7 and round up, you get a 1. Take the 1.8, round up to the nearest integer, you get 2. 2.1 rounded up is 3, and 3.1 rounded up is 4. Okay, so those are just points that are on our step function, but let's graph what the step function looks like. I'll start with just we know that if x is a negative 2.4, so on the x-axis, negative 1, negative 2, negative 2.4 is around here, that our function has a value of negative 2. So I'm going to go down to negative 2, and I'm going to draw in my step right there. When our x is a negative 1.4, negative 1.4 is right here, we apply the ceiling function, and we're at a negative 1. So it's going to be that whole step right there. And this pattern just continues. So we're going to fill in our steps of our step function. And then we're going to talk about, well, maybe we should have done that first, but I think we'll be okay. I'm going to fill in the last two on the other side. So I think you can see why this is called a step function, or why it's a type of step function. A ceiling function will look the most consistently like stair steps going up. So we need to have open or closed circles on the ends of these little steps right here. So what we do is we think about if x is a negative 5 and we round that up, our y value would be a negative 5. So there is your step function, and in particular, this one is a ceiling function. We also get to talk about a floor function, which we had in our vocab. We're going to fill in the same x values and see how a floor function affects those outcomes. So we're going to fill in the column for the x's, negative 2.4, negative 1.4. And by the way, these x values, there's nothing special about these. They are just values that force us to do our rounding, either to the nearest integer up or the nearest integer down. We could have picked different x values, so don't think that these are not special in any way. Sorry, x's, you're not that special. Okay, so now we have a ceiling function, which means we're going to round down. So if you apply a ceiling function to negative 2.4, it's going to round down, which means it gets smaller, and that's going to round it down to a negative 3. If you apply the ceiling function to a negative 1.4, it rounds it down to a negative 2. We have to be just real careful with our negatives. If you're applying the ceiling function to a negative 0.5, it rounds it down to a negative 1. All right, now the positives are straightforward for us. If you round a 0.7 down to the nearest integer, it's 0. 1.8 rounded down is 1. 2.1 rounded down is 2. And 3.1 rounded down is 3. All right, so now that we understand, it's going to look very similar to the last one, just those steps might be in some different spots. So if we go to this first one, when x is a negative 2.4, our function has a value of negative 3. So that step is going to go right here. So I'm going to go ahead and draw in that step. And if we go through each point, because it's a floor function, it's going to look just like the other one. We just had to know where to start that floor function at. All right, now let's figure out our open circles and closed circles. Maybe we'll look at the positive ones this time. If our x value is a 3, all right? So if you round a 3 down, you get a 3. So the y value is a 3. I'm going to go up 3. So this point right here is on our function, so that's going to be a closed circle, which means the one below it must be open because I can't have two values of x be equal to 3 and it still be a function. When x is a 2, you apply the floor function, you round it down, it's still just a 2. So 2 right here is on our function, so that will be closed, which means if I go down, when x is a 2, it would not equal a 1. So this is going to be the same pattern. Each little step will have an open circle and a closed circle. And it's consistent, looking the same. Just make sure we can tell, are you drawing an open circle or a closed circle? And the reason we have to have these circles is there's just an overlap in your x values. So we have to know, well, when x is a 4, is your y value a 3 or a 4? And that's what the open and closed circles help us determine.